Hey, just wanted to show you the difference between voltaic and electrolytic cells, just as a brief overview here. Obviously, voltaic cells are what convert chemical energy to using chemical reactions to produce electrical energy like we find in batteries, etc. And electrolytic cells are just the opposite, and they convert electrical energy, so you put in electrical energy and we can make a chemical reaction happen, so like electroplating, something like that. Okay, and so we're just going to have a look at each of the different cells and how we label all of the parts, and we'll go through that and have a look. Okay, so we'll first start off by looking at voltaic cells, and these are made up of chemical reactions that are spontaneous, so they happen by themselves, but we want to harness the electrons when they're transferred. And so to do that, we have to separate the two different half cells. So we do that by putting them in separate containers, where we put some kind of barrier between them so that they don't that they react in the proper way. In other words, we force the electrons through an external circuit so we can use them. Okay, so we're going to use a voltaic cell with a copper and a zinc half cells, and at each of those different electrodes, there's one possibility for each one that they're going to oxidize. In other words, the zinc electrode here is going to oxidize by losing 2 electrons, or the copper is going to lose 2 electrons and oxidize. And the one that is more reactive is the one that's going to do that, because reactive metals oxidize more easily. And we know that zinc is more reactive, so this one is actually the one that's going to happen. So this one does not happen. In fact, the reverse happens. In other words, it's reduced. So let's write that reaction. Okay, so essentially we have copper ions reducing on the surface of the electrode, producing copper metal. And so actually the mass of the copper metal is going to increase. The opposite happens on the zinc electrode, where the zinc metal is actually going to oxidize and produce zinc ions on the right-hand cell there. Okay, so all that happens, and what happens is I'm losing some positive charge here because my copper ions are disappearing. So the left side of my cell here this is becoming more negative. Okay, and on the right side I'm producing positive ions, which means that this is becoming more positive. And so that won't work because we have to have a balance of charges. So to figure all this out, we have to balance out the charges using something called a salt bridge. Okay, and a salt bridge is just like a U-tube like you've seen with potassium nitrate in it. Potassium nitrate, because those ions don't really do anything, they don't react with anything, they stay soluble, they don't adhere to any electrodes or anything, they just balance out the charges. So my potassium ions are going to move here to replace the copper ions that have been used up. And my nitrate ions are going to move here to balance out the additional positive zinc ions that are being produced. That keeps everything balanced. And the question then is, what happens to those electrons? These electrons here that are being used up, and these ones here that are being produced over here. So that means electrons are being produced here. They're leaving here from this side, okay? And they're arriving here, okay? And so because we know the direction of electron flow, it has to be that way. There's no other place for electrons to go. This is how we force electrons to go through the external circuit. And it looks something like that, okay? So zinc is a more reactive metal. It's going to produce my electrons. And because electrons always move from the negative electrode towards a positive electrode, that's how we label them, okay? So zinc, or electrons rather, move from the negative electrode to the positive electrode, okay? They're repelled by the negative electrode, attracted to the positive electrode. And so that's why we label the electrons, positive and negative. And then in terms of which one's the cathode, which one's the anode, just remember that reduction always happens at the cathode. So red cat is what that means, okay? So this over here then is a cathode, and it happens to be positive in a voltaic cell. This here is the anode, where the oxidation occurs, and it happens to be negative in a voltaic cell, okay? So the next video we're going to look at electrolytic cells and see how that's a little bit different.